the registering of the session. Yes, with respect to this registration, I received an email from some department at the university telling me that at some point I have to delete the videos because it seems that they do not have space. So do not worry, I will put them on YouTube as I've been doing. I have missed some. I think that last week and this week I was a little bit lazy and I didn't upload the YouTubes on the videos on YouTube, but I will do that and then they will be on the site of the course. So if for some reason you cannot attend or that you have connection problems, etc., always refer to the site of the course and then you have the slides, the instructions, the videos, etc. So independently of Blackboard, because it seems that there are not many storage resources, and so there are limitations on that. So it's just because today I deleted the recording, so maybe someone will try to have a look at some of the material and then you discover that it is not longer available. So I will notify this, well, after the class, I will upload everything so that you can have access to that without depending on the storage support of Blackboard. Okay, so today is practice day. So I'm going to introduce general elements of Mongo, and then we start with the practical example. What we will need is that you launch your Compass, you connect to Atlas, and that's it for the moment. And then please open the PDF with the instructions of what we are going to do, so that you have all the material ready to use, and then I will do a lot of things together with you, and then eventually I will ask you to do independently some aspects, but we will work together today. Okay, so well, as we said, we are going to have a look at Mongo in a very particular setting, because what it's important to see is that we are really using a cluster provided by a cloud provider, which is Atlas, MongoDB Atlas. We'll have a look at how they control the consumption of the processes. You will see now that you have been using Microsoft Azure, that it's all more or less the same principle, where you can follow the consumption of the different resources that are allocated to your free trial account. And eventually it also proposes that if you are willing to scale, then you can have another subscription, but with that subscription you can have access to a little Mongo cluster consisting of 3 nodes. Just let me open here my, it's not this one, it's this one. Okay. But I'm not sharing. Sorry, it's like being a DJ here. You have to, and I'm not. I don't have practice. That's a problem of not being a professor and being just doing research, that you that you lose a little bit of practice. Okay. So as we said, Mongo is a document DBMS. It was created a long time ago in 2007. It provides public licenses and is one of the most popular document document storage solutions that are today in the market. And this is why I chose to show you it, because as you are preparing for the labor market, so it's important that in your portfolio you can say that you learn how to use Mongo for the querying level, and with some uses of an advanced use. Okay, so general technical characteristics that are important to bear in mind, so that you always have the architecture that we are deploying in your mind. So it's very important that in your minds you have the picture of which are the processes that are running, where are they running, and how are we interacting with them. Okay, normally, as you have seen in the Azure example, the classic way of interacting finally, even if we are in a cloud setting or another type of setting, is that we use client-servers architectures. Okay, then we have evolutions of the classic client-server architecture with different tiers, but at the end, from process to process, we use client-server architectures. Now, then another aspect that we have seen is the data model. Mongo has a document data model based on JSON documents. Okay, so what we are going to manage within Mongo are JSON documents, which is a semi-structured data model with no fixed schema. So there is a structure as in any document, but the structure can vary depending on the documents that populate the database. Then it provides this version, the very new versions of MongoDB have evolved, and at some point, NoSQL systems realized that asking programmers to program the whole bunch of queries that they would have to program was too much. Okay, so they provide, as we will see, some predefined built-in operators that we can use in order to express our queries. So it's possible to do complex querying, meaning that we can project, we can filter, we can have join-like operations, we can perform aggregates, and then we can implement other operations under a parallel model, which is the MapReduce model. Then it is possible to serialize objects, which is called the binary JSON model. So you have your JSON document. You can consider it as a kind of object. And now you want this structure to go to disk. And so you need a protocol that will go through the elements of your document and that will create the right data structures in order that will reside on disk, on hard disk. And this is serialization. You might know it from Java, the lack of solutions. So MongoDB adopts this serialization using BSON, which is the binary representation of JSON documents. Then, in order to deal with distribution and particularly with replication, MongoDB uses a technique, a fragmentation technique. You have probably studied fragmentation in your advanced course of databases. So it is a technique, a fragmentation technique, but adapted to non-relational data structures, and in that case, it is called sharding. Okay, the fragmentation, the jargon is sharding. Then, in order to go fast and to have the possibility to access documents across the cluster, it uses B+ trees indexes. Then, based on this fragmentation, it also uses duplication in order to distribute data, copies of the data across a cluster. And then you can have many host programming languages, so you can interact with it in C, C++, Erlang, Haskell, Java, a lot of them. With Python, I hope that at some point I will show you how to connect from a notebook. Now that you get acquainted to notebooks, we can use, for example, Colab and connect to MongoDB, and then use Python in order to program operations on top of notebooks. Now, with respect to, let's zoom into the matter. So, of course, I will use a relational as reference because I suppose that you have a little bit of expertise on it. So, in the relational world, the unit of the data model is the relation, so the tuple. In MongoDB, we are going to deal with collections of documents. Okay, so the unit that will the container where you are going to store your documents is a collection. Then, if you compare it with the tuples of a table, every document can be considered similar or equivalent to a tuple in the relational world. So you have the container collections, and then you put inside documents. Then the documents, of course, have attributes because we are using JSON. So we can have, in the relational world, we only have atomic attributes due to the first normal form. In MongoDB, we do not longer have the first normal form, which means that we have atomic attributes. We can have table attributes, and we can have JSON attributes. And they are recursive, so you can have attributes of attributes, okay? So, and thereby have complex data structures. And then you have the notion in the relational world, you have the notion of schema, which is the representation in intention of your database. So it's just the definitions of the sets of tuples. And in the case of Mongo, there is no fixed schema, as we have said, and the documents are auto-described. Okay, so comes a first document within a collection, and then the system considers that this is a first reference structure of the documents within a collection. And then comes another one with some variation, and then it knows that in general, this will be represented by some structure, but at some point, some of the attributes might be absent, and this is not a problem. Now you have an example. You have students with first name, last name, email, etc. And so the schema would look like this, where you have attributes, typed attributes. And in the case of Mongo, of JSON, a JSON document would look like this. One important thing to consider is this. You might be used to it because you know that, for example, Java objects have identifiers, so object ID. So here you have also the notion of a unique identifier of an object, which is different from a key. I'm not going to discuss this with you now. Eventually, we will have this discussion. This is just a unique identifier, so documents are identified automatically. MongoDB names them, provides them with an identifier, and then you have the attribute value structure. So for students, you have a first name, you have a last name, for example, an email, and then an option, which is the career that you are studying. So we have, this is one student, and here you have another student. And together you would have a collection of students. I want to mask this. I always try to mask this, but when I do this, I lose my, yes. So each little structure representing a student is a document, and the attributes are key value pairs. This is important because this represents the data model supported by the system. And then I have said about the identifiers and available data types. Now we are a little bit of reasoning as if we were learning a programming language. So you have classic atomic data types like string, bytes, integer 32, 64. We have doubles, we have booleans, arrays, which is now different from the relational. We have ISO dates, and then JSON document, of course, or object ID. So the object ID represents the fact that you are dealing with a data structure that represents a document that grabs together a set of attribute key structures. How is this going on? That it doesn't. Oh, yes. And now an important thing to think about is what about connecting documents together, making reference. So in the relational case, we have foreign keys. In the Mongo case, what you will use is either there are two solutions. Either you embed, since you can have complex data structures, you can embed a structure within the document. So for example, if we want to deal with the marks of a student, you have everything that we have said, and we can have an attribute marks, which is a collection of documents again, where you have course and the name of the course and the mark of the course. And now you have these little documents which are collected by this marks collection. So in that way, you build these data structures. And well, if we refer to what you know in the relational, it's no longer neither the first normal form and nor the second normal form. Okay. But you can also have other ways of doing this, and it is by dealing with references. Since you can access to the reference of an object, you could have, for example, a collection of marks and a collection of students, and connect the marks to students thanks to the object IDs. Okay, this is really looks like a programming language. So you're not discovering anything new. The only thing that it's new is that in order to deal with data collection, you can use this kind of strategies in order to connect documents together. And again, if you are acquainted with XML, for example, there we can use references in order to have complex XML documents. So this is more or less the case. And now, if you think about data structures, it's always important to have to think about data structures. Without references, you have trees. In fact, your documents were represented as trees. And if you add the possibility of referencing objects among each other, then you come up with a graph. Okay, and this changes the cost of dealing with this, and particularly navigating through the different documents. So this is important because the decision of either having a complex data structure and dealing with your objects can have its importance if you really have a lot of documents and you want to scale, because one will harm the scalability if you deal with a lot of documents, even if the system is optimized for that. So this is what I have said. If you are acquainted and you are good users of UML, for example, instead of having one-to-one, you have one-to-n associations. And as I said, having one-to-one or one-to-n associations has an impact on the performance of your management. Okay, so this is what I wanted to say. And then basic operations, CRUD operations, insertion, deletion, update, and we can query, we can aggregate, and then we will have a little touch on index management because we are looking for performance. And there are indices. At some point, we will go through indexes today. I'm not going to go to this. Okay, so Mongo in practice. Let's have a look on how we'll see in a minute things in Mongo. So first of all, that you have already done because you have uploaded your the restaurants database. But in fact, you can create collections that are empty and then one by one add some documents. Okay, so you are going, as this is in MySQL and in others, you have seen that. In fact, the system manages databases, and within a database, you will have collections of documents. Okay. So here, for example, we have the database students, and within these database students, we are going to insert these little documents. And then we can insert one by one or insert many. This is when we are programming, we can decide how to insert, which strategy to use to insert. But anyway, this will look like this. Then, of course, you can delete, but that we will see in practice. So every time, so it's navigational. So you have to give all the path that the system has to use, and then it's an API. So since we are using an API, in fact, we are calling methods that have parameters. Okay, so it's a sort of programming expression, but with methods already built in that we are going to call in order to perform operations on top of data. This is like an object-oriented thing. No? So you can again update, but that I will not stop on this. It's just to give you an overview of what you will see, and you can modify sets. You can modify any data structure that Mongo manages, and then you can query. So we are in fact going to start with querying exercises. So you can, in fact, what you're doing is lookups. So you know the set of collections that are associated to a database, and then you choose a collection and you can say select star, no? And select is the operator find, and then you can either select everything or with this just saying find something on students, and it will provide you with all the documents stored in the collection students. And then you can add other things. For example, you can project on attributes and say, I want to retrieve all the documents from the student database, but only I am interested only in attribute ABC of the document. So these kind of things. And it looks like that. It's quite verbose, okay? So it's a language, but it's a little bit verbose. And then there are some hints that guide the way you want to retrieve your documents. So by default, it shows the ID, which can be a little bit of a burden because you have the object ID. So if you say that you do not want the ID, you can say that ID is 0, and so it doesn't project on ID. Otherwise, ID is always projected in your solutions. your results, then you can filter by parameter, by a value with respect of a parameter. For example, here I'm looking for a student whose last name is Solo. Then you can also have existing. Now here you have the notion of existence, and because you are you are never sure that all the documents have the same structure. So you can ask, for example, whether an attribute X, for example, let's say attribute telephone exists in the documents stored in the collection, okay? Or you can ask to get the documents that have a specific attribute. Yes, this kind of thing. So you are going to play together with the values of the elements of a document and with the structure of a document. Okay, so since there is no schema, so the schema is no longer separated from the data. So you can reason and you can operate on the structure of the document and on its values. And then, of course, you have Boolean operators. You have you can have operators in order to deal with arrays. You can have comparisons. Well, it looks like that. Okay, so you have everything is an operator. Okay, so you have to express the things like that. And well, with many different comparison operators on the values of the attributes of the document. And then, as I said, you can have aggregations, which is quite useful in order to have an overview of the values of some documents. You have the notion of group. Too, you have the notion of match, because at the end you are navigating within the data structures of the document. So you look for patterns of structures of data of structures of a document that correspond to some pattern. Okay, so you use match for that. And then, of course, you can have order, associate an order to your results and ask, for example, a decreasing order with respect to the value of an attribute or an increasing order, etc. I'm not going to go through details with this because, well, we're going to have a look at all these, but in practice. So really a TV overview of Mongo. So let's go into the matter. So I need you to, as I said, first of all, we are going to have a look to Atlas. Okay, so just let me make sure that you can see I'm going to stop sharing and restart sharing so that you can have a look at my browser. Okay. Why doesn't it present my browser? Are you having a look at my desktop?
Yes, Jerry, we can see your desktop.
Yes?
Yes.
I have two screens, so in my second screen I cannot see, but if you can see, it's fine. Okay. So now you're having a look at my Atlas, right?
Yes.
Okay, perfect. So you can open your own Atlas, and if you were curious, you should have seen the following. So first of all, as you have seen, Atlas reasons with respect to organizations. Okay, so my organization is called like this. You have, of course, named your organization as you wanted, and then once you have created an organization, then you can have a project. No? And so my project is called like that. And within the different tools that provided by Atlas, you can deal with databases, and then you can deal with data lakes. At some point, we will touch in our course the notion of data lake, just to give you a general understanding of a data lake. Data lakes are evolution of data warehouses without a multidimensional model. So you have, and then you have other services like defining triggers in order to observe the status, for example, of a specific project or cluster that you could have, or if you arrive to a certain amount of consumption of resources, you can define triggers so that you, as an administrator of an Atlas cluster, you can know that you are reaching some limit of data, of consumption of other resources, and that you have to pay attention on your processes. So this is a service that is provided by Atlas, and there are other data APIs that help you program. And if you do not want to have a look at the portal all the time, you can have widgets. You can program widgets using the data API and have an independent observation of the way you are consuming resources in Atlas from these little widgets that you could program. And of course, you can have access control on your databases, on the IPs, for example, of valid IPs that can access the resources that are available on your Atlas. This is also possible. And once you have this, then, for example, us, we have deployments of the database. Well, my database is called DBAEGI. And the consumption looks like this, no? So I have, well, first of all, here it's stored in my case, in Belgium, in Europe West data center. It tells me the version. It tells me that in my case, it's a sandbox. It has 3 nodes for replica sets. Since I'm using the free trial, no backups are possible. There is no application linked to this server, and I could eventually create indices and other things. Then, well, I have this. Then you can have monitoring, closer monitoring with respect to different metrics that you can deal with in order to understand how you are consuming the resources of your cluster. Again, instead of having this, you could have a widget if you have you are in an organization, so that it could look at these kind of things. Then you can observe the collections that that you are dealing with. Myself, I have a lot of collections. If you started to play with it, you might have many, but one of them is, for example, the collection restaurants that we are going to use. You can have searches, so it's a control portal that can help you deal with your resources and with your cluster from this control. Once you have this, then well, in the case, well, this is a Mongo solution, so the idea is that you have these servers running in some data center, and now, as I said, we need a client, because we will work on a client server architecture, so a 2-tier architecture, and therefore what I asked you to use, and what I recommended to use, was Compass, okay? So Compass can be a client all on a MongoDB that you could have stored locally in your machines, but since we are playing with the cloud, we decided to externalize everything, and then for the time being, the cluster is created automatically by the Atlas solution. At some point in the course, we ourselves, well, in fact, in the next Mongo example, we ourselves are going to build a cluster. And then you can have in Compass, what you have is the different hosts towards which you can connect. So I have several of them. All of them are on Atlas, and I'm connected to one of them. And this one of them presents the different data collections that I have and that I showed you from the portal. So this is yes, a view of what you have in this case in your cluster, and then you have this part of the of Compass where you can have many different things. So, for example, in the case of the course, the exercise that we are going to do, we have, and you uploaded the collection restaurants, and here you have, well, it's a kind of easy to use. Let's think like this way of exploring the data collection. So you can have a look at your documents. If you have predefined aggregations, you can have a look at an aggregated way on the content of your data collection. You can have a look, for example, to the schema of the content of the documents that are stored in restaurants. If you click there, an interesting thing to see. In fact, it generates a set of statistics that it needs in order to make decisions on how to execute operations, and particularly how to distribute the data across the nodes of your cluster. Okay, so for every attribute in the documents, it provides you with the statistics, the distribution of this attribute, okay, of the values of the attribute. It also says, for example, when it was created, at what time, for example, for the ID of a document. No? Then you have address. An address, for example, it's a nested attribute. It has 4 fields, and the fields are this one. One is a string building, and the distribution of the values is this one. Then you have coordinates, which are geographic coordinates. And look at this beauty. It tells you the distribution of the coordinates. So where are the restaurants located within the world? So we have restaurants here in Vietnam, I think, and then the rest of the restaurants are here in this area of the world. And of course, you can explore this, okay? You can make zoom ins and zoom outs. This is to understand the content of your collections, which is quite normal because in the relational model, we didn't have to do this because the schema had a description of the content. And we know that all items in the content of the database respect this data structure. And since we know the data types, we can know eventually the interval of values that we can have. Then, of course, we can run statistics, and the relational database runs statistics in order to determine the distribution of the values. But the schema tells us a lot about the content of a relational database. Here, we do not have this because there is no schema. So if someone gives you data collections like me that I provided you with restaurants, then a practical way, if you are really going to use it in a realistic way, you have to you can use Compass and then have a look on the different elements of the content of your database in an aggregated manner, which helps you, instead of going one by one understanding what is going on in the collection, you can have this aggregated view of the collection. So you see, for um, every attribute within the documents that we uploaded in the restaurants data collection, we have this distribution. See, here's, for example, in neighborhood, we have the distribution like this, etc. Others are arrays. Again, it has, see, for everyone. Okay, so that's it's a way of complementing the fact that you do not have schema, and that you, as a user, the one who wants to explore the database and is going to write the queries, can have a guide on how the queries can be written. Then at some point, now that we are going in a minute to execute the queries, I'm sure that you remember from your fundamentals of databases that every query has an execution plan and that can be optimized. And if you want to understand the performance of the system, an important tool in order to understand it is having a look at the execution plan of the query, how it was organized, so that you can understand why it's running fast or not as fast as you have expected. So it provides you with this, and then for the time being, well, here I have created an index on the ID. So you can create other indices associated to your data collection. It is always to increase performance, and you can have this, and then you can have other validation rules. So at some point in the theory presentation, I insisted on the fact that there were no integrity constraints. Yet in real life, at the end, you are representing a mini world. And the thing is that normally there are business rules that are representative of the type of the way you want to manage your data. And you can either you implement them at the application level, or, well, here Mongo has quite evolved, and you can add some rules to your collections. For example, you could say that if you are with the famous employees and departments, you could say that no employee is aged younger than 18 years old, for example. If we were in a country that does not accept children to work, okay? Or no, within a hierarchy of the organization, the positions of the highest positions in hierarchy cannot earn less money as the lower positions in the hierarchy, or no one can earn less than 1,200 euros per month, for example, in order to respect the minimum salary. These kind of things can be added to explicitly here. But again, it's not as in the relational model associated directly to the documents. This is an external way of having control on the content of your documents. So this is the, I'm going to go back here to documents. Normally here, for example, me that I chose these restaurants, you see where are you in the databases that you have. So I have a database called sample restaurants, and within it, it has 3 collections. And so I'm here. And then, of course, it gives you the size of the documents, etc. that you can have. And there is one index and the total size and the average size of the documents. Now, in order to query, we can have this. I hate this, but it's intended to be simple, to simplify the way you are going to express your query. In fact, it has the operators that you can apply, and here you write what you want to search for. Okay, but it's a kind of disaggregated way of expressing your queries. I find it very, very uncomfortable, and particularly for pedagogic reasons, I'm not going to use this, so that you can see the queries completely and not fragmented like this. Then you will be able to decide if you like this or you like the engineering way of writing the queries, and you can choose. And then here down, you have a Mongo SH, so a terminal. And I'm going to use the terminal to show you and to work with you with the queries. So let me come up here. So at the very beginning, you will have your prompt. And the first thing that you have to say is activate, well, go to the database that you are going to use. In my case, the database that I'm using is called Sample Restaurants. Okay, this depends on how you created your database and then how you inserted your collection within this database. So in order to activate, to switch to the database, in fact, it's going to the right address where it stores the documents. You have to use the command use. Okay, so here I'm saying I want to use the database called, in my case, Sample Restaurants. And when you do this, well, it tells you that you are there. And then you have the prompt again. Now, the first thing that we are going to use is, I'm going to use this just to make it simple. We are going to do select everything. No? So I'm going to say that, okay, I'm already in Sample Restaurants, that that I want to use the database, well, the collection restaurants, and find, execute the method find in order to obtain all the documents stored, contained in my collection restaurants. So I will have it here. So here it's an engineering view. Huh? So I have a lot of restaurants. So it gives me all the collection of the restaurants. So if you get one of them, as you can see, you have, as I told you in the overview, you have the ID of every object. Then there is an address, an attribute address, that it's in fact a data structure consisting of the following well, in fact, it's a set of documents. No, it's a data structure, sorry, that contains the following attributes. It has the number of the building, the coordinates, geographic coordinates of the location, the name of the street, and the zip code. Then it says the quarter, so the borough where it is located, the type of cuisine that proposes this restaurant, and then a collection. This one is a collection of documents. You see, here you have the collection of documents, and these little documents are the grades, so how it was scored. So every document contains 3 attributes, the date of the evaluation, the grade assigned to by this evaluation, and then a score, which is the average of grade of the grades done during a day. Then you have the name of the restaurant and an ID of the restaurant. Fine? Until here?
Yes, all clear. All good.
Do not hesitate to tell me if you at some point you get lost. I understand that it's difficult to go back and forth and having a look at the system and then listening to me speak and explain. I really encourage you to do what I'm doing, so to make sure that you get the message, and then eventually you can be independent and do other things. So once we have this, as I said, this TV show introduction to MongoDB, we can have a look at the exercise that we are going to perform together. Okay, so part of the exercise we will do together, and then at some point I will leave a kind of homework that you will have to do on your own, and produce some document where you describe the results of what you have seen. But for the time being, we are going to work together. So in order to work together, yeah, and find the specification of the example, you can go to content in the, I'm going to put on the chat, if you do not have it in hand, the address of the course. So you have it here, and I'm going to put it on Slack if some of you are following Slack. So it's in both parts. And you have here Mongo examples. And so you click on Mongo examples, and you have the first assignment, which is here, no description of the first assignment. So if you click on here, you will land on a PDF document. So you already have your server on Atlas. Well, I gave the option of using Robot 3 or Compass. Just one comment with respect to Robot 3. Robot 3 is this one. So it's a kind of application. It more or less looks like Compass. You know, you have here your shell where you express queries, and then here this window. Let's see if it is connected. No, I'm not on the right. Oh, yes, well, it doesn't matter. So you have this kind of solution. This is an open source solution of a client that can connect to Mongo or Atlas, depending on what you use. This is to say that you yourselves, I mean, if we were in a distributed systems course, for example, a kind of project that I could ask for is that you build this and that you program this kind of client, okay, by your own. So Robot 3 is the case. So this is an open source community, but you could, for example, build a startup where you develop such kind of solution. Let's imagine that you put it in a more fancy way, and you give more facilities in order to interact with your Atlas or with with local Mongo, and that it can reside, for example, I think that you are having a course on mobile applications. So imagine that you have a widget that can be installed on your phones or your tablets, and you provide such kind of solution so that someone could easily use Mongo in a fancy manner and a simple way using your solution. And then you build a startup and you sell the solution. Okay, these kind of things could be done by new engineers, newly finishing their education, for example. Okay, so and then we have the data sets restaurants. Now, what do we have to do? Well, in fact, you will see we will have to run a lot of queries so that we get acquainted to the different operators that can be done and how we can play with documents collections. And then at some point, it guides you on the way that you can index your collection and compare the performance of your queries when you have indexes and you don't have indexes. Okay? So this is the kind of exercise that we are going to perform. So in your case, what I'm asking to do is the part of the indexing is the one for which you are going to write a report. You have to create a PDF named like this, and then to be uploaded the 13th of February. Okay, so that's the administrative instructions, and then let's go to serious things. So we have restaurants. We have seen more or less the structure of the documents. And the first question that we have to answer, I am listening to your proposals, is list all the restaurants in the collection sorted in an increasing order of names. I'm going to give you a minute to think about this, and what I'm going to do in order to prevent you from looking in this mirror, I'm going to stop sharing my screen, and I'm going to I'm going to listen to your proposals, and then at some point I will put what I propose in the chat, and then we can run it. Okay, do not hesitate to run and have tries on your tests. So what do we have to do? Well, first of all, I mean, if we can imagine a strategy, so we are looking up for things. So the operator that at least I have presented until now is find. No? So I have to find what? So if you see the question is, I want restaurants and I'm interested in names. So at some point I have to project on names, which is another attribute on name. And then I have to find a way to express the fact that I want to use the operator sort, in order that my result is can be ordered. So while you are preparing to see, what do you think about this? It's on the chat. So if you have a look on the chat, I'm specifying this is something that we have to do on the shell. We are on the database restaurants. We are going to have a lookup on the collection restaurants. So find. I am using the whole collection, and then I am projecting on name, and I want to sort in a decreasing order. Okay, so you see, I retrieve the collection in the expression. I project on name, and then on this result, I apply the operator sort, and the parameter is I want to sort with respect to the attribute name and in the corresponding order. So if you try this on your shell, I'm going to share again so that you can have a look at that. So I did the following. Let me try to zoom. So, right, you're seeing. So I am finding on restaurants, I'm projecting on name, and I'm sorting the name. And what do I obtain? A lot of garbage, you see? And this is the first thing that happens when you do not control the entry of the documents, that you can have many documents that in fact are incomplete or are just dummy documents that were inserted in the database. So if you have a look at your result, you will see a lot of objects where the name is an empty string. Comments, questions? Please.
Yes, I have a question regarding why we have
Yes.
in the first argument of the find function, it's an empty square bracket.
I'm going to show you the I sent today no, it's not. Sorry, I'm gonna stop. I'm just going to open a document that will help you to have a look at the specification of the methods. Okay, so just give me a second. Um, I'm putting the document here on the chat, and I'm going. So well, want to share again. Screen, tac. I want to close for a while my compass. I have a festival of sorry, of, oh, okay. So this is the MongoDB tutorial and reference guide. So here, in fact, what you need is to be acquainted with the parameters of the operators that we are using. So in fact, what happens is that when you it has many different possibilities. The first one is like doing a select from star, which is using the method without any data, any collection, without specifying anything within the parameter. And then when you specify, when you want to operate on the collection, you have the brackets here, you are saying that you are you are interested in any attribute within the collection that you are referring to. In the case of the example is inventory. So you do not have, if you are not projecting into anything, you can exclude the brackets, okay? And this leads you to this. But then if you are going to project, like in the exercise where we need to access name, now you have to create the container that is represented within the brackets. And then within that data structure that it's created, you are going to navigate within its content. And this is why you need the brackets. So in the case of our example, it says restaurants. Then you have the empty brackets to say that you are retrieving the whole collection, and within that collection, then you are going to project the attribute name in all the contents of the documents contained referred to in these empty brackets. Okay, and now that you have this set of documents projected on name, now you operate and you apply the function sort. Just because it's just to create the right data structures in memory so that you can operate on them. Okay, because we are in fact programming. Okay, it's like creating a variable. So you create a variable, but it doesn't have a name, where you obtain your documents and then you operate on the content that you have retrieved from the collection.
Oh, okay, so it's just a
Convinced
way
or not?
to initialize.
Yes, it's like, yes. I mean, it's like creating a variable where you are going to get all the content, the contents of the collection.
Okay, I see now. Think it's true.
You're welcome. Other questions? Okay, so let's go for the second one.
Yes, teacher, I have a question.
Tell me.
I was forgetting. So why do we have objects? Yes, objects.
Object IDs,
That have
because
name empty.
because it's litter, because the collection contains documents about restaurants where nobody specified a name. They leave it like empty string,
Oh, okay. So
right? And in fact, it is presenting just a part of the collection. At some point, it will present, if you go through the whole collection, at some point, you see that there are, in fact, documents that contain name, okay? But it's just
Okay.
because it's litter.
Oh, okay.
And
I see.
and we said that try with a decreasing order. Just give me a second. I'm going to stop. No, not stop. I'm going to close this. Sorry, this is a festival of Windows. If you, instead of 1, you put -1, it will be the opposite order. What is my compass? Here. So I'm going to try the following to see if I'm not telling you wrong. Ah, yeah. Oh, I did something wrong. But I won't try it now. But if you do it in the opposite order, then stupid things I'm doing. Then eventually you can see names. Let's try this one just to see, to show you. Here what I said is I want only documents. Well, I want documents that where the name is not empty. I want the name and I want to sort them in a decreasing order. Okay, so here I explicitly said not to present me documents that do not have a name. And now you can see that some of the documents have a real string that corresponds to a name.
Oh, okay. I see.
You see, so it's here I'm asking, I want to find documents that, and you see this is my container of documents where I'm filtering my documents, where name, the attribute name is not equal to empty string. And once I have this collection filtered with this filter, not equal to empty string, now I am saying that I'm going to sort the corresponding documents. So I project on name and I sort them with respect to name in a decreasing order. And there you can also tell me, well, you see, you have here these characters, you see these ones or these ones that are kind of a little bit of litter. And now my decreasing order is kind of blurred because it depends on the representation, the ASCII representation, no order. Because not all of them are real names, as we can see in a natural language. Some of them include these kind of characters, but since no one provides a restriction on how on the way the name should be inserted, so you have this kind also this kind of little litter in the names of your restaurants. Okay, so I think that we are reaching to the end of the session. So what I'm going to ask is the following. For next Thursday, I will ask you to, well, during the week, or you can do the first part of the exercise, which is only querying, okay? And then on Thursday, what we will do is you have to come with questions, okay? So to have a try on the queries, and then if some of the queries you really think that it's impossible to do, it doesn't matter. So bring a list of those that you could answer, those that you couldn't answer, so that we have a discussion on the way this can be expressed, okay? So that you can by your own and in a zen manner play with these queries, so that we can discuss about what you managed to do or not on Thursday, and then we can move to do other things, more advanced things on Mongo. Fine. Questions, reactions?
Excuse me, doctor. I have a question, but it's about one of the hands-on activities for the
Yes.
lab. I want to ask, let me check it.
Yes.
It says there's a partial, no. The hands-on one, service as unit of construction, and hands-on one, understanding externalized settings on the cloud. I wanted to ask, on what state are these two activities due?
Hands-on one. Well, first, hands-on one is on the hands-on lab, no?
Yes.
Okay, so so this is not about this course, it's about the other course. So for hands-on one, there's nothing to. Oh yes, I'm sorry, I'm reorganizing my ideas. For hands-on one on the lab, next Tuesday, what you have to bring is a first try on the functional architecture of the setting that we prepared for that exercise. So it's a figure. And the idea that will be that we are going to work together, discuss, compare the figures, so that at the end you have a good picture of the different elements composing the infrastructure that we used in order to deploy the simple application on Azure. So it's a figure, and it's due. I mean, it's due. You have to bring it to on Tuesday so that we can work together, but you do not have to upload it until now. Okay, at some point you will have to upload it, but this will be part of the evaluation of the first term of the I mean of partial number one. But for the time being, there is no date due.
Okay, so just for next Tuesday, only the figure. Okay.
Yeah.
Thank you very much.
You're welcome. Other questions about the schedule? So just to make sure that you bear in mind, so that you can organize also your activities. So there's the figure to be discussed, but it's just material that we will use for the lab. For this course, the idea is that you have a try on the exercise on your own, so that we can discuss the queries, but there is nothing to be handed in, okay? And there is a reading, and there you have to hand in the Google form for Monday. No, there is a reading exercise. Are you aware of that? Yes, I suppose. Okay. So the only thing that you have to really hand in is the Google form on Monday. Good. Okay. So if there are not other questions, I see you on Tuesday. Tell me, Mauricio.
It's just a comment that, well, some of my classmates wanted me to let you know is that Carlos Ruben Acosta missed the class today because he is sick with COVID, so he couldn't
Oh,
attend.
sorry. Yes.
Yes.
Um, just, I mean, if again, if people are missing something, well, we are registering, so when he feels better, he can have access to that.
Okay.
I'm
And you,
sorry to
and
hear that. Take care.
yes, I will tell him.
Don't get crazy and go touch everyone.
Yes, I will tell him. And
Good.
and also David Diaz. Well, it's more of a
Yeah.
personal issue, but he also couldn't make it today. So I told him the same that he has to see the
Yes,
recording.
please. Yes, everyone, if you get contact to people that cannot connect for some reason, tell them that all the material, I mean, up to tomorrow, the recording and everything will be there so that they can have access to it. Yeah.
Okay, perfect. Thank you, teacher. Have a nice weekend.
You're welcome. Have a nice weekend.
Have a nice weekend, doctor. Thank you.
Mhm. Thank you. Take care.
You too.